Hello, my name is Hans, and this will be my Q2 big project video for physics. For now, I'll be explaining the conservation laws of momentum, power, work, impacts and impulse, elastic and inelastic collisions. Work is done on an object when force acts upon it in the direction of motion or has a component in the direction of motion. For example, work would be positive if I were to lift the box like this, and work would be negative if I were to lower the box like this. The force would still be upward, but the displacement of the box will be downward. Momentum in physics refers to the quantity of motion an object has. If an object is in motion or it's moving, then that object has momentum. Momentum can be basically defined as mass in motion. For example, a huge boulder rolling down the hill has momentum because of its motion. Compared to a small stone, the huge boulder has more momentum because it has more mass than a smaller stone. In physics, power is the rate of doing work. It is the amount of energy consumed per unit time. In the SI unit system, power is measured by joules per second. Power can be represented as work over time or mass times gravity times height over time. As I'm going up the stairs, power can be determined by the amount of time I take to reach the top and the height of the stairs from top to bottom. Impulse is basically the change in momentum. To change the impulse, you either change the force or the time interval in which the force acts on. This is an example of impulse, elastic collision. In this situation, a ball is moving to a person's face at 10 meters per second, weighing at 0.2 kilograms. The ball leaves the person's face at 5 meters per second. The question is, what is the impact on the ball from the person? The impulse equation is F times delta t equals to m times delta v. F is for force, delta t is change in time, m is mass, delta v is change in velocity. For now, we know the change of momentum is final momentum minus initial momentum. Momentum is mass times velocity. In this case, since we're finding final momentum and initial momentum, we put m times final velocity minus m times initial velocity. M for mass, v for velocity. We put in the numbers for m, which is 0.2 kilograms. Final velocity is 5 meters per second. But in this case, negative 10 is the initial velocity, because since momentum is a vector, it moves at a single direction, which is right. Right for positive, left for negative. Since the ball is moving 10 meters per second going to the left, it makes 10 negative. So we solve the entire equation, which we will have as 1 kilograms meters per second minus negative 2 kilograms meters per second. We have an answer of impulse is equal to 3 kilograms meters per second. An impact is a high force or a shock applied over a period of time when two or more bodies collide. An elastic collision is when two bodies collide and the kinetic energies are conserved. The two bodies will collide to each other and will bounce back. An inelastic collision is when the kinetic energy is not conserved and the two bodies will stick together. This will be an example of elastic and inelastic collisions. Now I will be explaining the centrifugal and centripetal forces. Centrifugal forces is an outward force acting on a revolving object away from the center point. A centripetal force is an inward force acting on a revolving object towards the center point. In terms of planetary motion, the Earth's gravitational pull pulls the Moon towards the Earth, which is the centripetal force. As the Moon revolves around the Earth, the force going outward is the centrifugal force. But due to the Earth's gravitational pull, the Moon just goes along its orbit, revolving around the Earth. This concludes my Quarter 2 Big Project video, and thanks for watching.